Okay, so for this problem, we are given the following system block diagram, and we're asked to find three different things: the transfer function, the poles of the system, and the impulse response of the system. Um, those are all dependent on each other, so it's really kind of just one problem, and these are all things that we're going to find essentially just by solving the equation. So, um, one hint is if you haven't seen this operator before, this A operator, that is the integrator operator, and essentially it just means you multiply by 1 over s in the Laplace domain, and because it's easier, we're going to be working in the Laplace domain for this problem. So I've labeled some nodes on the block diagram, and that's in order to kind of explain how this is working for simplicity. So we'll start with B right here. So we can see that kind of comes down from y, it goes through that a operator, and then it gets multiplied by 1/2. So b is just simply going to be 1/2 of a times y. And then in the next portion, over here at c, we can see x is coming in, and it's going to be x minus that b that we just solved for right here. And so that's just going to equal the x minus c, which is 1/2 ay. For the next portion, we have d, and you can see all d is c, but multiplied by that integrator operator again. So we're going to have d equals a times c, which is going to equal a times that quantity, which is x minus 1/2 ay. This next step, we have e, and we can also see that that's dependent on y again. It's dependent on y coming through this way. Kind of just like the b signal, it's going through that integrator operator and then being multiplied by 3/2. So we get e equals 3/2 ay. And then so our final output, y, we can see is just going to equal d minus e. So d minus e, and that's going to equal this right here, the a times x minus 1/2 ay minus 3/2 ay, which was the e that we just found. And then, so now the rest of the problem is essentially just doing a little bit of algebra. We're going to have right here our y equals ax minus 1/2 a squared y minus 3/2 ay, and all that is just factoring out this equation for y, or essentially multiplying a through is all we're doing. And then in the next step, we're isolating y and x on each side of the equation, and that's in order to be able to find our transfer function. We need to be able to divide y by x, which will give us h, our transfer function, and that's just going to equal a over the 1/2 a squared y plus 3/2 a plus 1. And then, as I said earlier, that a operator is the integrator operator, so multiply by 1 over s, so a just equals 1 over s essentially, and when we substitute that in, we're going to get this equation right here, and that's just changing a to 1 over s is all we did there. And to get this in a form a little bit easier to work with, we'll multiply by s squared over s squared, which will turn our function into that right there. And it's kind of easy to see on this one that denominator is factorable. You get 1/2 times 1 is going to equal 1/2, and then 1/2 plus 1 is going to equal 3/2, and then obviously our s squared. So that's a pretty easy factorization, and so that would actually be good enough if all we had to do was determine the transfer function h equals y over s. So that would suffice for that answer, but and it actually, I guess I'll go ahead and explain that real quick. Part B of the question, determine the poles. The poles are just the roots of the denominator, so our poles are going to be -1 and -1/2. So up to this point, we can actually sufficiently answer question A and question B. But part C of this question, determine the impulse response. The impulse response is a time domain function, so we'll have to take the Laplace inverse of our transfer function here. And in order to do that, back to the basics, partial fraction expansion will give us this equation right here. a over s plus 1 plus b over s plus 1 half is going to equal our original transfer function. Essentially what you end up doing is you multiply through by the denominator. You get this a times s plus 1 half plus b times s plus 1 equals s. And in order to solve this, you essentially pick the values of s that are going to zero out your equation. So if s equals 1 half, this term becomes 0, and you get b times negative 1 half plus 1, which is 1 half, equals negative 1 half, so our b is going to equal negative 1. And then to zero out this b term, we're going to set s equal to negative 1. So you'll get a times negative 1 plus 1 half equals negative 1. So a times negative 1 half equals negative 1. You solve that, and you get a equals 2. And then all you have to do is back into this format we had up top here, just plug in the coefficients that we found, a and b. So you get 2 over s plus 1 minus 1 over s plus 1 half is our transfer function. And then at that point, this is a very, very easy Laplace inverse. You can look at the table. I'm sure most of us have it memorized by now. That's just going to equal 2 times e to the negative t minus e to the negative 1 half t. This is just that basic form from our Laplace table where you take e and raise it to the power of the root of your denominator. And then obviously that 2 is just a factor that you can factor out or essentially keep in the equation. And that is it. We are done. Thank you.